Yeast and bread, the road to the rise.
Okay, so how does yeast leaven bread?
I'm not really sure. I think it's like an anaerobic process, but I don't really know why or how it works. I'm just pretty sure it's anaerobic, and that's all I know.
How does yeast leaven bread?
Through a fermentation reaction.
Yeast is a single-celled fungus that's actually related to mushrooms. Yeast might be a small cell, but they're actually one of the simplest eukaryotic organisms because they have a nucleus. But everyone is much more familiar with yeast looking like this. There are around 1,500 species of them, but there's only one that's most common in the kitchen called Saccharomyces cerevisiae, which means sugar-eating fungi, which is definitely a good name for it. This is our lovely sugar-eating fungi. Yeast release enzymes that convert the starch in flour into sugar, which they eat up and metabolize to do cellular work. During this reaction, they release ethanol and CO2, which forms bubbles and helps dough rise. Fun fact, active dry yeast was actually developed by Fleischmann's company during World War II so the US Army could make bread without having to keep yeast refrigerated. In order for yeast to live without a refrigerator, they gotta be dehydrated, making the little granules you see, which is a dormant yeast cell. Throw a little warm water on them and a pinch of sugar to feed them, and the foam that's produced means they're still alive. We cover it with a warm towel to ensure that we give them an optimal environment. We can see an evenly dispersed foam layer, which means our dormant yeast have been chowing down on sugar and soaking up all the warm water for the past 7 minutes that it's been resting. In other words, they're alive and well and ready to help our bread mixture rise. Flour is added into the mixture of yeast, sugar, and salt. Two proteins in flour, glutenin and gliadin, grab water and make a bubblegum-like mass of molecules, also known as gluten. For bread in particular, we really want to build as much gluten as we can because it straightens the dough and traps the gases, helping it rise. As you can see, it's a very messy process, but if you're not making a mess, are you having fun? The bread dough needs to be kneaded. Little food pun for ya. But leavening agents like yeast would be bubbling messes without something to contain them. Enter flour. The proteins, when combined with water, form gluten, and as we knead the dough, the gas bubbles from yeast become trapped in our stretchy network. Yeast and kneading are essential for developing the gluten network. The rising is built on sort of a molecule-by-molecule kneading. CO2 is bursting and releasing air bubbles, which gives water and the proteins in flour a chance to come together and build gluten. After our little forearm workout, it's important to let the dough rise. Yeast has got to metabolize those starches into sugar and inflate a network of air bubbles. I was so excited my dough rose, I forgot to video it, but it came up to the top of the bowl for a reference point. While it was rising for an hour, heat from fermentation was building up in the middle of it. Yeast were packed in groups, alcohol and CO2 was building up and rising the dough. Kneading it out again gives it a fresh start, a little pick-me-up if you will. Packed groups are distributed, hot and cold spots are evened out, ethanol is spread out to make sure flavor is good. Because of all our effortful kneading, we have a very stable dough mixture because we've built up that gluten network. So go ahead and shape the bread however you like. Plop it down on a cookie sheet covered in cornmeal to prevent it from sticking and score the bread. This is to help it expand during baking because as you know we've built up a lot of CO2. Covered it in some water to prevent moisture loss as well. Steaming helps keep a soft crust. When steam settles on the surface of the bread, it dissolves sugars in the dough. When the bread stops expanding and steam evaporates, the sugars are left behind to caramelize. It's baking time, folks. You can see how much the CO2 helped the bread rise, and we have that nice caramelized top. Alright, let's see how our gluten network turned out. Just going to cut into this, and hopefully we see nice big pockets of air bubbles.